So here we have the graph of an absolute function. It's given by y equals a absolute value of x minus h plus k. And we know that this graph has certain characteristics that we cannot ignore. First off, absolute value function has a vertex. That's the point of the v. And it always happens at the point h comma k. And is symmetric in the line x equals h. So x equals h is going to be a vertical line, so essentially we're going to always have a line of symmetry that goes through the vertex. Okay, and it's going to be vertical. The graph is obviously V-shaped, we already know that. It opens up if a is positive, and opens down if a is negative. And the graph is wider than the graph of y equals absolute value of x if the absolute value of a is less than 1. And the graph is narrower than the graph of y equals absolute value of x if a absolute value of a is positive 1. So here, a kind of determines which way does it open up or down. That a also determines if the graph is fat or skinny. All right, so here we're going to start off by writing the equation of the graph shown, then we're going to state the domain and range. First off, to write the equation of the graph. This is true for any function. X and y are always going to be left alone in our final answer. What we need to figure out is h, k, and in this case we're also going to need to figure out a. Alright, well h and k is always my vertex, and it's always the point. So this is my h, this is my k. So h equals 0, k equals negative 3. Alright, so what I have now is some extra point, x, y. This is just some point that lives on the graph. Well, I probably need to use that. I don't have any information about a. So what I'm going to do is plug in my hk, plug in my xy, and solve for a. I have to know a to be able to write the equation of this absolute value function. All right, so what I have is y equals, I'm just using the rule up here, that's in your notes, so I have 1 equals a times the absolute value of, let's see, x, which was 2, minus our h, so minus 0, plus k. And our k was negative 3. Now what I want to do is clean this up as much as possible, so I have 1 equals a times 2 minus 0, so absolute value of 2, positive and negative is negative, so minus 3. Well, I want to start getting a by itself, so I'm going to go ahead and add 3. Cancel out. So I have 1 plus 4, or 1 plus 3 is 4, equals a times the absolute value of 2. But absolute value of 2 is just 2. No big deal there. So I have 4 equals 2a, which means if I divide by 2 on both sides, that a is equal to 2. So now that I know a, and I know my h and k, now I'm able to use the rule that we introduced right here. I'm going to plug in for a, I'm going to plug in for h, and I'm going to plug in for k, what I know. So I get my answer is y equals 2 absolute value x minus h plus k. Alright, so now what I want to do is clean up as much as I can. Obviously, x minus 0 is just x. I have y equals 2 times the absolute value of x plus, or actually positive and negative makes a negative, so minus 3. That's my final answer. That's the equation of this graph. If I graph that, which I'm going to, I should produce this same graph here. So I'm going to say 2 math, go to the number menu for absolute value, x, be sure you close it up, that's very important, minus 3. Graph it. All right, well that looks pretty similar, but I want to verify these points, so I'm going to go to the table, so second table. All right, I'm supposed to hit 0, negative 3, I do, and I'm also supposed to set 2, positive 1. I do. So I've hit all the information that I've given, I've got it in my graph that I created, so I have the right function. Now, we're also asked to state the domain and the range. Now, this is where things get a little weird. First off, domain is our input values. In this case, it's our x values. Again, 99% of the time when we're talking about domain, that's our x values. So what I'm thinking about is my domain And all I'm looking at is the graph. To find the domain, all I'm looking at is the graph. If I go all the way, if I follow the graph, well, I can keep going right. Keep following the graph all the way off the screen, but I can keep going right as far as I want to. Well, if I can do the same thing with my graph, I keep going to the left, following the graph all the way as far as I want to off the screen. That means I can go as far right or as far left as I want to with this graph. So since I can do that, that means my domain is all real values, or all real numbers. So all real numbers. Now my range, I'm looking at the y values of the graph, and just the y values, okay, because we're looking at the outputs. So notice that my y values are restricted. No matter what I do, I cannot go below -3. No matter what I do with this graph, I cannot go below -3. -3 is the lowest point. So I'm going to call my range, but I can go up as high as I want to. There's no restrictions up here. So I'm going to call my range, it's going to be y has to be greater than or equal to -3. Now it's equal to because there is a point that sits on -3. Okay, so it's very important you include this line. So my domain was all real numbers. My range is y is greater than or equal to -3. And that's it for absolute value. No big deal. Again, you need h and k, which is the vertex. You're probably going to have to solve for a to determine which way it opens and is it skinny or fat. Plug in what you know and get your function. Then, once you have the function, look at the x values for domain, look at the y values for the range. We'll do some more practice with domain and range as we go on in this chapter. If you got questions, let me know.